Section 6-6, Part 1. Selecting the most efficient method to solve systems. Inspect the equations. Decide whether the addition method, subtraction method, or substitution method would be the most efficient algebraic method to solve each system. Remember, a system is two equations, and you are searching for the point that the two equations intersect. The point is your answer. You can solve them by the addition method, subtraction method, or substitution method. So we're going to be choosing which method is the best method to use for each one of these systems. So let's look at system number 1. System number 1 is given 5p plus q equals to 4, and 4p minus q equals to 5. When I look at this system of equations, I first look at my two variables. I see that I have two p's and two q's. They are lined up, the equal signs are lined up, and my constants are lined up. Now begin looking. Is one of the variables the opposite of the other variable? As far as when you look at the q's, are these opposite of each other? I have positive 1, negative 1. Yes, they're opposites of each other. Another word for the word opposite is additive inverse. Additive inverse. So these two are additive inverses of one another. They're also opposites of one another. When you add these two numbers together, you get 0. Positive 1 minus 1 gives you 0. These would cancel. So notice I said when you add these together, they cancel. So that would be the best method when you have two variables that are opposites of each other. The best method would be addition. So for number 1, your best method would be addition. Because if the variables cancel, the q's cancel, I would add here, I would get 9p equals to 9. Dividing both sides by 9, I would get p equals to 1. And then I would take the value of p, plug it back into either one of the original ones to find q. So the best method for number 1 is addition. Next, let's look at number 2. For number 2, I have y equals to x plus 3 and y equals to 2x minus 9. So looking at this problem, they are lined up, but also I notice they are lined up, but also I notice that they're already solved for a specific letter. So if you already have one of the equations solved for a specific letter, the best method to use is substitution. Substitution would be the best method. We would take what y is in the first equation and substitute it into y in the second equation. So anytime that you have one of the equations solved for a specific letter, the best method to use is substitution. So that was number 2. Let's go to number 3. Looking at number 3 now. Copying down number 3, 7x plus 2y equals to 10, and 7x plus y equals to negative 16. Okay? So let's decide what method would be best for number 3. Now, when I look at these, I see that they're lined up. They're not solved for a letter, therefore substitution would not be the best method. So it's either going to be addition or subtraction. For addition, you're looking for one to be the opposite of the other. Well, when I look at the x's, they're not the opposite of the other. I would need negative 7, positive 7 for them to be opposites. And these are not the same. I have 2y and 1y. So being that they're not the opposites of each other, the best method for this problem is subtraction. When you see that you have two x terms that are identical, the best is subtraction. Or if I had two y's that were identical, the best method would be subtraction, because when I subtract here, these cancel. Now 2y minus 1y would be y equals 2, and 10 minus negative 16, so 10 minus negative 16. Remember, when you're subtracting, you must change two signs. That becomes 10 plus positive 16. Anytime you have minus and negative, that's plus plus, so you would get 26. And you can also do that on your calculator. You get 26. So you're subtracting each one. 7 minus 7 canceled. 2 minus 1 gave me 1. And 10 minus negative 16 gives me positive 26. So I could easily find y. I would take what the value of y is, plug it back into either one of the original problems, and solve for x. So the best method for number 3, since my two x's were identical, was subtraction. So now let's go back to number 4. The fourth one here. Number 4 is 2a plus 5b equals to 17, and 6a minus 5b equals to negative 9. So when I look at these two, I see they're not already solved for a specific letter, so I don't need to use substitution. I do see that everything's lined up. When everything is lined up, we're either going to use addition or subtraction. So look at each one of your A terms and your B terms. When I look at the B terms, I see that one is the opposite of the other. That is what we call their additive inverses of one another. And when you add two numbers that are additive inverses of each other, you get 0. So the best method here would be the addition method. Let's add these two linear equations. When I add, the 5b's cancel because 5 minus 5 gives you 0, 0b gives you 0. So here I would add 2a plus 6a would be 8a equals to 17 minus 9 gives you 8. So I could easily solve for a by dividing both sides by 8, and therefore a would equal to 1. To find b, I would go back and substitute in a back into either one of the original equations. But the best method was the addition method because these two are opposites of one another. Now let's look at the last system of our problem number 5. 3x plus 2y equals to 10, and x plus 2y equals to negative 8. So here we have number 5. I notice that they're lined up. Therefore, the best method is going to be addition or subtraction. The only time you will want to use substitution is if one of the equations is already solved for a specific letter. In other words, if you just have y on one side by itself or x on one side by itself, then you would want to use substitution. So we're not using substitution. We'll use either addition or subtraction. So let's begin looking at our x's. These are not the same, but look at your y's. These are the same. If they're the same, we use subtraction. So we will use subtraction on this problem. If they're the same, like my two y's are, they're both positive 2y, positive 2y. So if they're the same, you use subtraction. Like on number 4, they were opposites of each other, therefore we used addition. So when they're the same, you use subtraction. So now we could subtract 3x minus 1x gives you 2x. These would cancel if you subtract 2 minus 2. And then 10 minus negative 8. You have to be careful on that. That's 10 minus negative 8. You have to use the minus sign. 10 minus negative 8. Because here you're saying 3 minus 1. 2 minus 2. You've got to say 10 minus negative 8. So when you subtract, you must change two signs. That becomes 10 plus positive 8, and you get 18. Subtraction means add the opposite. You can also punch that in your calculator. 10 minus negative 8 gives you 18. So we end up with 18. Then we would divide both sides by 2, and x equals to 9. We would take 9 back in, plug it in for x, and we could solve for y. Plugging 9 back into either one of the original problems, we could easily find y, and therefore we would have the point of intersection. So the best method for number 5 was subtraction because the two variables were the same.